Brain-computer interfaces, BCIs, are a relatively new technology that has been gaining traction in the last few decades. They are a technology that seeks to bridge the gap between the human brain and a computer, allowing the two to communicate without the need for physical input or output devices. In essence, BCIs are systems that allow people to interact with computers without the need for keyboards, joysticks, or other traditional input devices. At its most basic, a BCI is a device or system that allows a user to control a computer with their thoughts. It works by recording electrical activity from the brain, usually via electrodes attached to the scalp, and then deciphering the recorded signals to determine the user's intention. For instance, if a user wants to move a cursor on a computer screen, they can think of the movement and the BCI will be able to interpret the signals from the brain and move the cursor accordingly. Although the concept of BCIs has been around for decades, it has only recently become feasible to build practical BCIs. This is thanks to advances in neuroscience, computer science, and engineering, as well as the development of new technologies such as the fractional Fourier transform. These advances have enabled BCIs to become more precise, accurate, and reliable than ever before. Despite these recent advances, BCIs are still in the early stages of development, and a number of technological and ethical issues must be addressed before they can become widely used. For instance, the accuracy and reliability of the BCIs must be improved before they can be used in mainstream applications. Additionally, the ethical implications of using BCIs must be taken into consideration before they can be used in medical or security applications. Despite these challenges, BCIs hold a great deal of potential for a variety of applications. For instance, they could be used to help people with disabilities interact with computers, enabling them to access the same information and services as everyone else. BCIs could also be used in medical applications, such as helping paralyzed patients control robotic arms or legs. They could also be used in security applications, such as allowing people to access secure information without the need for passwords. In the future, as BCIs continue to improve, they could even be used to augment or enhance human cognitive abilities. For instance, BCIs could be used to help people learn languages faster, or to give them access to knowledge that they wouldn't normally have. The possibilities are endless, and only time will tell what the full potential of brain-computer interfaces will be.